Hey guys, it's Matt from Eastwood. We're here in the Eastwood garage doing another live tech session on YouTube, Facebook, and also eastwood.com. For any of you guys that haven't watched this before, we want it to be as interactive as possible. And we have Scott over here on the chat.
Yeah, so if you guys have any questions, make sure that you hit me up, Facebook or on YouTube. I'll be able to answer you right then and there, or I can also always throw the question over to Matt so he can answer it. So back over at you, Matt, so you can get up and start welding.
So today we're going to be covering a question probably we get every time we do a broadcast about welding. We get a question on what type of welding should I use for my project or in my situation, my garage. And I figured I would go over the different types of welding, show you guys what's involved in doing them, and I'll give you a couple instances where they're good to be used and maybe where some of the weaknesses of each type of welding are. And then, hopefully you guys can kind of interpret that into your own garage and, make a decision when you're picking a machine or a type of welding that will work for you. So today the machine I'm using is the Eastwood MP200i. Now the reason I'm using this machine, quite frankly, is it does all the welding functions in one machine. So that's really handy in the fact that we can go, and I'll show you guys, we can go from MIG to TIG to stick with very, very little effort. I have two bottles on the back here. So for TIG welding, we're going to need 100% argon. And then we have a CO2 mix over here on the other bottle that's going to be shown for MIG welding. So that's why I have two bottles. If you see me messing with the bottles, that's why. So the first one I'm going to show you, I'm going to start with probably the most basic welding that requires little materials, and all the way up to, from there. So first what I'm going to be doing is arc welding or stick welding. This is pretty much the other than oxyacetylene welding. It's the first type of welding that most people have done. So with this, it kind of looks, we have our ground clamp and then we have our electrode holder. They look pretty darn similar, basically the same thing, it's just a clamp. So we have our ground clamp. I'm going to put that on the table, and that's connected there. Then we're going to put our electrode in. I have this connected in the machine. Now inside the electrode holder, if you guys will try and get a shot here, there's little grooves. There's little grooves inside of there. Those grooves, like that, like that. There we go. Those little grooves are so that we can grab our electrode however, our rod, however we want. So depending on the angle you're in, if you're overhead, if you're welding vertical, you may need to put this in the different directions. So whatever ends up being most comfortable for you, is kind of the end story. If you can put it down a good weld, that's what really matters. But you may need to change the electrode depending what you're doing here. So that's what those different grooves are. You just kind of angle it. And arc welding requires no gas. So there's nothing, we can take this out, this welder out, hook it to a generator in the middle of nowhere, whether it's on the side of a trailer if you're doing 4x4, or even if you got a farm or around the house and you need to work out in the field or out in the yard to fix something, you can take this guy out there and use it without a bottle. You don't have to drag it out, which is nice. So the rod, what happens is the rod has a coating on it that may vary in color, but the rod actually, when it burns, it creates the shielding gas that some of the other types of welding that we're going to show you actually is put into the weld. So when we weld and it burns it off, it actually creates that gas that shields the weld. It kind of does everything in one shot with this. So this type of welding, and I'm going to do a thicker piece here. And we got this guy here. So when you're welding with most stick welders, you basically have to drag your stick or your electrode. You have to strike an arc on the piece, whether you touch it or you scratch it. That's what you need to do to actually create the electrical connection so that we can weld. The other thing to note, if you're switching back and forth, you do need to turn your helmet up considerably when you're doing this type of welding. A lot of welding I do in my day-to-day is TIG welding and on thinner gauge steel. So I have my helmet turned down quite a bit. But for what we're doing when you're stick welding, it's much, much brighter. It creates a lot more spatter. So just what's going on, what you're actually watching, you want to make sure that you're turning the shade up. I have my shade here just about at a 12 if you have an Eastwood helmet. That's where I keep mine set at. So we're going to come in close here, and I'm going to do a weld here. We're going to get under hood of each so you can see the process. And then we'll show you afterwards what you get at the end. So when Joe's ready, he will come over here and get his fancy lens set up. And then I'm going to shoot. You could probably come right here for this one. Yep. I will admit I'm probably a little out of practice with stick welding. I don't do it very often. But let's see what we can do here. So I'm going to get real close and got a round clamp connected correctly here. Oop. Let's turn to, sorry guys, got to turn the stick there. It was MIG weld in the beginning. We're going to turn the welder up pretty high here. Now I should be ready. Sorry about that, technical difficulty. So when you're welding, you have to actually move the rod closer as we're welding and you're moving across. And when you get to the end, you pull the rod away. So now we'll show you what the weld looks like afterwards. You can see the rod, you can kind of see here on the end here, you can see the coating on the rod on the outside, and then in the center is the actual rod that we're burning, the metal that's actually going into the weld. So once you start burning it away, you can tell a little easier. So then with the weld, what you get is you get some spatter around the weld here that you can see. That's this normal occurrence. Now you also have a coating that basically ends up on it, a core that's over it, MIG slag that, or I'm sorry, arc slag that's on this. So we can just tap this and knock it away. Let's take a wire brush here real quick. Underneath. So you have to knock away that core to actually see the weld. On the back side you can see we're getting nice penetration there, the 1/8 inch steel. I had this turned up fairly high. I had the machine turned up just about all the way on this machine, about 170 amps on this, or 174 technically. That's where I had it dialed in at. So it worked nice. We got nice penetration. Now this type of welding is good for heavier steel. It's good for doing again, stuff when you're doing outdoors. If you're doing heavier work on automotive, like some framework and things like that, you can get by with using a stick welder if you have it dialed in right. It's not my favorite, but it does penetrate well. It is strong. It just requires some additional cleanup where you need to knock off the slag, grind the weld down, or at least clean it before that you're going to paint it. I'm going to stay on stick here, and I want you guys, because we deal with automotive so much, I'm going to show you on sheet metal what ends up happening here. So I'm going to turn the machine way down here. Let's go to, I think I had it around 30 amps. Seemed to be a sweet spot here. A little more difficult doing this with these little tiny rods here. So I'm going to put one of these small little rods in. I got a piece of sheet metal here. We're going to test my arc welding skills here because this is a tough one. Got that clipped in. So we're going to do a little weld along here. I did a couple test passes earlier just to get set up, but we'll try and do one of these and show you guys what we get. When you're doing sheet metal here, oh. Gotta hold my piece here. There we go. The rod bounces around is the problem. Come on. There we go. So again, you got to move the rod in. You got to be moving along pretty quick. And this thin stuff is pretty hard to get started. You got to have the touch on top of not bouncing the rod around because it's so thin. So you can hear much quieter. I have the amperage turned way down. So this machine is an inverter, so it's much quicker. I'm sorry, much quieter than what you may be used to hearing when you're doing some of this welding. Now we'll show you the actual piece here, and the warpage that occurs on sheet metal is using an arc welder is much higher than some of the other methods. But with the machine turned down, if you can dial your machine in quite low like this, you know, we're still getting good penetration. We're not burning through real far, which is pretty good. But it does take a little more effort, like I said, to start. That's why I was struggling there in the first beginning section. And you got to move a little quicker and be real careful as you're going because it'll burn right through instantly. So this is on just a flat piece. If you're trying to weld a seam together, it gets infinitely more difficult if you're welding something thin like this that's 20 gauge. So I would not, for automotive type use, I don't recommend using an arc welder for doing projects on automotive use, where, especially if you're going to be painting or something like that. Because of the warpage that happens, it's not that great. But if you're fixing something that's, say, a tractor or something like that, or maybe it's just a car that you don't really care that much about, or you're not worried about making the panels real straight, you can do the job with it just like this. Requires no gas. This is the cheapest way, basically, that you can weld with an arc welder. So if you want to just jump into the welding process, this is a good one to get started on, because all you need is rod, a machine, and you're ready to go. So that's arc welding. Do you have any questions so far, Scott, that you're...
Right now, the only one we got so far was just seeing if you'd be doing what you were doing would have been better with MIG or TIG, you know, because you just tuned in, and certainly it could be cleaner, but we're getting a good showing of all the different style welding today.
Yeah. So again, we're showing the different types of welding today and giving you some tips on which one is better. So arc welding, again, if I'm talking to you and you have an automotive project, arc welding, the only time I would really use an arc welder is if I'm doing frame repairs or heavier fabrication. Or if you're out, some of you guys are off-road guys, you need to repair something out in the field, you know, an arc welder is perfectly okay. But if you're doing a restoration and doing sheet metal work or body work, I do not suggest using an arc welder. There's other welders out there that are more affordable, or if you have a machine like the MP200i, this does all three different types of welding, so you can do all of them with it. So that's arc welding. Now to turn this machine to stick weld here, all we need to do is go to this little switch here on the face, and we're going to click down to MIG welding. And we're going to swap over. The numbers are going to change a little bit here. Now we get the wire speed is on the left screen here, or is the left knob, I'm sorry. Before, the left screen was showing you the amperage for arc welding. So we're going to dial that in, and then on this side is the voltage that we have for the wire. So to show you the process for that, I'm going to take our stick welder, lead out here just so I don't get tangled in cords. And now we're ready to show you guys MIG welding. So the MIG welding process we've now transferred to using a gun type setup, or where we have a trigger, and you'll see wires coming out. We have solid core wire on this. There's two different types of wire welding. There is MIG welding, which uses gas, and there is flux core wire welding, which is probably the closest thing to stick welding in which you don't use gas. The flux core has a coating on it that when it burns, it also burns off and creates the shielding gas. So we have our wire coming out here. I have a MIG function today, so we're using solid core wire. We're using our mix gas. And trim that off. So we'll show you these different types. So I'll leave our arc welding piece there. And for the MIG welding process, the technique for welding, instead of you constantly have to be pushing your hand closer like you do with arc welding. With MIG welding, the wire is coming out at the workpiece. So we can lock ourselves in to a height that's comfortable and good, and we can just drag our hand across at the same height because the wire is constantly feeding out of the machine. This makes it easier to weld. If you need to get into tight areas, it's a little easier because the wire is going to come out past. You don't have to get your hands in necessarily. And we can dial the machine in between the wire speed and the and the voltage. We can dial this machine in, and we have a little bit more control over what's going on. So I'm going to do a little weld here with the MIG welder, and we'll show you guys under the hood the difference in what it looks like, and I'll kind of try and talk you through it as we go. So make sure we're on our MIG function here. And Joe's getting set up here. He's getting pretty good at this close-up under hood welding business. And if you guys have any questions in between each of these processes of welding, I'm going to be I'll answer any questions you may have. Scott's answering them throughout the whole entire broadcast for you guys. All right, so all we need to do is keep it just above the workpiece and hit the trigger. So you can see it's creating a little more, it's creating spatter, but not quite as much. And now we can show the difference here between the two of them. I think we ran out of wire there. So the spatter that was involved, there's a little less spatter, obviously. And we don't have to chip off a coating on it. It's much cleaner as far as what the coating that's on it. On the back side, getting good penetration. So this one's going to require a little less cleanup than the previous. Does create spatter still, but because it has that shielding gas, it's a little less spatter. You can see this arc welding piece has it everywhere, and the other one is a little closer around on it. So for this type of welding, this is kind of the all-around welding that you can do pretty much anything with. You just change out the thickness of your wire, or you change your settings, and you can weld everything from thick all the way down to thinner stuff like sheet metal. So the only difference is when you get into sheet metal, it is perfectly fine to use on sheet metal. You just have to be a little more careful. I wouldn't generally run a full bead, regardless of what we were doing, the type of welding. I wouldn't run a full bead on sheet metal, especially with a MIG, just because you're going to put a lot of heat into the panel and warp it. So you can jump around, as some of you guys may have been taught, but a MIG welder works just fine for sheet metal. It doesn't have as much of a mess that happens. You can keep the heat effective zone a lot smaller than you can with arc welding generally. You have a little more control over the weld, So you can do some nice welds on thin gauge steel if you're doing restoration type work or repair, rust repair. That's no problem at all. Any questions about the MIG welding process?
Yeah, right now we have one if they want to know what size spool wire you can fit in there. And while you're in there, if you want to show it, if you can show like the drive assembly area, they want to take a peek in the inside of the door.
Oh yeah, of course. Yeah, let's show the. Now we got our Pro Cart here because this has 2 bottles on it. So I'm gonna have to turn this machine a little bit. Show you guys the drive setup on this. So with the drive on this particular machine, pretty simple. You got your 2 rollers here that's going to feed the wire, and each of these rollers, whether the type of welder that you're using, is going to have grooves in it in which the wire actually rides inside of the grooves. And on our particular machine we actually have 2 grooves on here, so you can flip the roller around and you can switch the types of the type of wire or the thickness of wire that you're using, no problem. We can show them how to change the wire if we'd like. I think we have 30 in here now. We'll show you guys changing it because we ran out.
Now's the perfect time to have that happen.
Yeah. 8. Yep, we're good. It's 30. So we'll show you guys how to change the wire since I ran out.
Good thing I was passing through.
Yeah, Randy was just passing through. Helpful bystander citizen.
Yeah, that's my good deed for the day. I gotta go back to feeding the homeless and helping the old people.
I think I'm closer to the homeless than anything.
Oh, that's 2 then. That counts as 2.
Yeah. All right, so I cut the end. I cut the end here closest to the motor here. It usually has a kink in it, and then what I like to do is just grab it up by the torch here and pull that mess out. So unfortunately, for you penny pinchers out there, it is sad you got to waste some wire. What I usually do with this extra wire, I TIG weld a lot. I'll keep this extra little bit of wire handy, and then I'll use it for doing sheet metal with TIG welding. So you can keep these little bits around. If you're a penny pincher like me, you can continue.
And that might come in really handy if you do any TIG welding later today on sheet metal.
Yeah. Yeah, maybe we'll use that. All right, so got this spool here. We're going to take this out. And it's got a little bit of a, again, it's always kinked on the end. This is the part that you don't want to let go of the spool. Not because it's going to hurt you, but because you're going to waste a spool by it unraveling. If you've had that happen to you and you're watching, let me know I'm not alone, please. It's happened to me a bunch of times. So you pop down this little lever here, flip up that one with the top roller. We're going to feed it through, and then there's a little guide that it goes through in. So just get that fed in there. I'm going to put this on before we get too far ahead of myself. The wire itself, Joe has a question. Camera guy Joe has a question. The tension that should be on this, you're asking? So Joe asked what the tension should be on this one. This one's actually spring loaded, so you can tighten it down. It puts some pressure but has a little give. You don't want to tighten this knob down all the way until it basically keeps this spool like from moving, because you can eventually tighten it down so much that now it's tight. And what that's going to do, you're going to start slipping the wire on the spool. So we want it to have some movement there. These little rollers are going to give us our grab in there. So the rollers, we'll get you a close-up of that groove. You can see the outside groove here, and there's the inner groove. So the groove, and then the top roller is flat, it has no groove in it, so it's going to push it down in the groove, and you can tighten this. This is spring-loaded as well. We can tighten that. And let's feed it through. There we go. Magnets are catching me. All right, so I like, just because I don't have good luck, sometimes you can hit the trigger here and the wire will come through and you get lucky enough that it'll just hit that little hole there, hit the little sweet spot. That doesn't happen to me. I gotta work to get it through the hole.
And Austin says that you're not the only one. He's done it too with a big roll of wire.
Yeah.
Let it unspool.
Yeah, it is. It's one of the most disheartening things that can happen to you is when you slip off the edge of that roll and the wire just goes boing. You're like, then I use a lot of words that I can't use here. So I'm hitting the trigger, letting it run through. There we go. Holy crap. So now you can just thread this on like so. Tighten this guy down. If you guys don't have a pair of our MIG pliers, these are really handy. You can use these to tighten everything up. Thread gas nozzle on. That tightens up. This is a Tweco style consumable, so this has threads in here instead of a clip-on like some welders have. So tighten that on, clip our wire off, and we're up and running. And I didn't let the spool unravel. I was sweating there for a second. All right. Flip that guy around, and we're ready to do some more welding. So I did a little short run until I ran out of wire on that piece there. I'm going to dial the machine down and we'll show you. I'm actually going to do some stitch welding like you would do if you were doing a body panel here. So I'm going to turn this down considerably. A little under like 5.5. I'm not going to turn the wire speed down a ton. Make sure we got our gas on here. Got some gas coming out. Clip this. And we'll do a couple little welds here. You want to get? Yeah, if you want to get one under the hood. I'm just doing little spot welds, so it might be a little difficult for those guys to see. I wouldn't suggest, in general, trying to run a bead too much on thin stuff. But so I'm going to show you guys doing a couple little stitch welds, and then I mainly want to show you what surrounds the weld and what occurs. So the reason I would use a MIG anytime over a stick on thin gauge stuff, you could see just the damage it's doing to the metal, or the shrinking that it's doing, is much less there. Now I didn't run a full pass, but it's just a cleaner. I mean, this we'd probably just need to grind a little bit or sand a tiny bit if we were trying to make it flush, and we'd be good to go. And on the back side, nice penetration. There we go. So MIG welding, I would say, is the best all-around welding process whether you're doing stuff that's just around the house, automotive, or anything beyond that. MIG welding is probably the most rounded out type of welding. I like to keep a flux core roll as well as a MIG solid core roll on my cart, because again, if there's something that you need to weld where you're out of gas or you just can't get the gas and everything out there, you can grab just the welder, click it over to the flux core, and put the flux core spool in. You can weld without gas, and it's still a little more controllable, I'd say, than arc welding in most cases, especially around the house. The other thing with this, with doing the flux core, or even stick welding, but with the flux core, if you have an area where there's a lot of wind around you or something like that, if your garage or your workspace, or if you're even working outside, if you're using shielding gas, it's going to get blown away and you're going to get a porosity in the weld. By using flux core, it doesn't need that shielding gas to get put out over the weld, so you can just weld in conditions that are less than ideal. You're not going to, regardless, be welding in something that crazy wind, but just a little bit of breeze would hurt MIG welding or any type of welding that requires gas. So that is our thick on those. So now what we're going to do is I'm going to swap over here, and we're going to show you a little bit of TIG welding. It's no secret that's my favorite, but TIG welding does require a lot more prep work. Takes a little bit more time to learn and can be a little more finicky sometimes. So on this particular machine, again, on all types of TIG welding, you're using argon. Well, 99% of TIG welding, you're using 100% argon. So we have a separate bottle here that I have on the side with our Pro Cart. So I just have that turned on. On this machine, our gas is actually it's just kind of an on-off switch here, but it's a valve that we turn on when I'm ready to weld, and it's just going to put the gas out at the predetermined pressure setting that I have on the bottle there. Now for TIG welding, it crosses over a little bit with the arc welding, but there's an electrode or a tungsten that's in the welder, and this, unlike arc welding, you do not want to dip this or push this into the weld while you're welding. And once you contaminate the tungsten or the electrode, it then makes the arc get larger, out of control, and you also can get a contamination in the weld. So much like arc welding, we're going to be basically just getting the connection from this electrode, completing the circuit with the ground, causes the weld to start up. With this, I got to switch over our ground. It's going to move over. To here, pretty quick and easy to switch over. Pull this forward a little bit. And then we're going to take our TIG torch here and grab the other end of the lead. That's going to go into where we had our ground previously. I just want to make sure this guy got a good connection there. All right, now we're ready to TIG weld. So we're going to switch it back to the center here on the MP200i. If we want to go to stick or TIG, we switch to that middle. That turns on this other display here, and you can see set at 108 amps. And I'm going to turn this guy up a little bit further here, 160. This machine is a fixed amperage, so when we start welding, we get what we get. So you need to make sure you have machine dialed in half decent for what you're welding. And we got this on stick here and TIG. We're pretty much ready to go. So I'll make sure my bottle's on here. And we'll get another under the hood when Joe's ready. Now, if you guys have ever done oxyacetylene welding, I always tell people when they ask, about learning TIG welding, it's probably the closest to oxyacetylene welding. I'm going to clamp this down too while I'm getting set up here. Because you're actually adding a filler rod to the material. Now you don't have a flame, but you have a current that's jumping and melting the metal, and you're actually adding the filler rod yourself. So you have even more control over the weld than you do when you are stick welding or if you're MIG welding, because you can give it more filler rod, or you can give it filler rod when it needs it to melt everything together. So you have a little more control over it. This does use gas. So again, we have 100% argon. The gas is going to flow out of the torch, out of this nozzle here. It's going to surround the weld. And then as we get a weld going, we're going to add filler rod and weld across. And this particular machine is has a lift start or scratch start. So you can hear I got the gas turned on. I'm going to work around this clamp here. Start the arc and we add our filler rod. You can hear this is the quietest of all of them. And you notice there's no sparks going on here. And when you're done welding on this machine, you pull your hand away, much like the arc welding. And we can close our gas nozzle. And we're done welding. Close that bottle up. Oh, actually, we're going to do a thin gauge here. So we'll show you the difference between, I'm going to pull all three of these back together. I know the MIG welder, I had a little, because I ran out of wire there, it got a little funky and didn't get the full weld. So, but just the difference in how clean the metal is. You can see the TIG weld, I mean, we don't need to do anything really to clean that up. There's no debris that comes off when you weld because it's only melting just a small area as we go, all the way down to the arc welding where it's a little messier. Again, we can grind and clean that up. It's still getting good penetration on all of them, on the thicker stuff, but this does require a little less cleanup. As far as difficulty goes to learn, I would probably say, honestly, a MIG weld is the easiest thing to learn how to weld as far as just get up and running. But the TIG welding is a little more difficult. You can get a cleaner weld. And that's the three of them combined. So now I'll try and do a little small section here on this piece so we got all warped the crap here. Now I'm going to switch to some thin, so you can use your thin MIG wire, or if you have the straight stuff there, you can also use that. It requires a little less work to use the straight stuff. You don't have to. All right, go down to. Come on. 34 amps. Let's try that. Get our bottle on. This tungsten is a 3/32. You can get different size tungstens. I would generally use something a little smaller than this if I was actually working on a project, but I want to show you guys just a different process. So we're gonna. Do you want to do this one too? All right. Now let me turn my. So now because we're welding such low amperage with a TIG, I actually need to turn my helmet down. I have it at about 9.5, 10, because this is much smaller arc. And whenever you're ready, Joe. I'm wasting gas. Yes. Dollar bills going out the torch end here. All right. Okay, now we're welding along. Now this doesn't like, I can already tell it doesn't like the metal, the dirty metal, so I prep everything the same, or lack of prep on everything the same. You can see I got the machine cranked down pretty low, and I can just weld the same as I was welding that thick stuff. Once the machine's turned down. So now I'm done. Pull away. I'm going to show you the differences between these here on the sheet metal. So the big thing to show is just how small the heat effective zone is for TIG welding. Much, much smaller. This was giving me a little bit of, I could tell it was giving me a little bit of a fit there because this has a coating on it. And with some of the other types of welding, especially, you know, like with MIG welding and arc welding, it doesn't really bother me too much. It just actually burns the coating off, or if you have a little bit of something on the metal, it burns it off. With these metals that aren't cleaned really, really well, it's giving me this gray weld. I could see there was stuff that was floating into the weld. So it wasn't as nice as I would have liked it to be. It's acceptable, but you're getting a little bit of dirt into the weld. With TIG welding, you need to clean the metal really, really well. I probably spend just as much time prepping a piece to TIG weld as I do actually welding it. So the back side, you can see, you know, they're all getting penetration. All of them are getting 100% penetration here. So we're getting a good weld on them. If this is a weld seam, we're getting weld all the way through. But the cleanup on these different ones, you can see that there's not much cleanup going on here. This doesn't have too much. The arc welding has quite a bit, and it's really warping it. So I would, if you can, you know, pick MIG or TIG if you can on sheet metal. We always get a question on which is better for sheet metal. You probably got it already, TIG or MIG.
Yep.
And I always say TIG is best if you can do it. But at the end of the day, whatever you're more comfortable with. If you can MIG weld really well and you're proficient at it, I would choose a MIG most definitely. So, I have any other questions that you?
Yeah, another one I think it's a good one to share would be
Sure.
I would be with the post flow with a standard unit where it's preset into it.
Yes.
You know, it'll flow for a certain amount of time, but with a scratch start, you don't quite have that. So if you were to be doing a thicker piece of metal, do you mind showing them how you would, you know, kind of lift it away and bring it back to end? You don't have to weld, but just how you can bring it back down so you're never far away, letting it cool the weld.
Right, right. Let me turn the bottle back on here. So, because this machine, you just turn the gas on. Is that a question, or were you explaining, or what was the question?
Well, it was a little bit of both. It's how to have the shielding gas still on the weld at the end, not just lift and end and walk away. Like how you kind of lift and then bring it back down again.
Yeah.
So you just demonstrate how you lift and then bring it back down, not
Yes.
to touch the panel.
Right, so we have the machine off, but yes, so when you're welding, you have to lift away far enough that you can terminate the weld, but immediately you can put your hand back down to just not touching and keep the gas there. With steel, luckily, there isn't much time that's needed for a post flow. So that time, you know, that you go up and down and keep it there for a second or so is plenty. You don't need to have it for, you know, 15 seconds or something. Post flow is mostly important on aluminum, stainless. That's where you really, really need to be careful with post flow. But this machine, with doing mild steel, and you can do stainless with this. You need to be, you don't have to be quite as crucial with it, but you know, a second and a half, 2 seconds is plenty for a post flow. So yeah, it's a good note in there that I forgot. Any other?
No, we're good.
Cool. All right, guys. Well, hopefully I answered some questions and showed you guys the differences so you guys can see for your project what might be the best welder process or the best welder to get. Again, the MP200i does all of those functions. So if you have one of these machines or you're thinking about getting it, just make sure you think about what you're welding and how clean it needs to be in the end in the prep work, and then you'll be able to answer that question after hopefully watching this video. So thanks, guys, for watching. Tomorrow we're live again at 3 o'clock Eastern Standard Time, and we're going to be doing some rust. So we're going to show you one of my favorite rust products that we have and show you how it works and a couple ideas for using that. So make sure you tune in. Thanks, guys, for watching. I'll catch you later.